Hi there, I'm Matt McGrattan from Digirati. I'm going to talk about using our IIIF manifest editor as a kind of on-ramp for AI and ML enrichment of IIIF resources. So I think we're all familiar with the fact that, digitized collection objects like books, archival records, photographs, artworks and so on, they're a natural target for automated transformation, description, and enrichment using AI or machine learning methods. And I think there are quite a few other talks in this conference that cover, interesting and exciting examples of that. And we know that the IIIF APIs, and especially the ability to annotate canvases, are a very natural way of making accessible machine-generated data for review and consumption. However, this process, isn't always as accessible and user-friendly as we might like. So I'm going to really be talking about the way that the manifest editor can be used to solve a kind of user experience and integration problem, rather than talking about the sort of nitty-gritty of the AI and ML side of this very much. So, the Digirati's manifest editor provides a user-friendly interface over the IIIF APIs. You can load and view existing manifests, you can create new manifests, you can edit the structure of those manifests, including ranges, which I think Tom Crane will show in one of his presentations. You can annotate canvases, and if you have integrations with our cloud services platform, you can also save and preserve those outputs, as well as just save them to local files. So I've got an example here. This is the manifest editor, and I'm going to create a new annotation on this. This is just a manual annotation. I can add an annotation page. I can draw a nice little box around the thing that I want to annotate. So, this is the kind of manual side of curating IIIF content using the manifest editor. It's nice and user-friendly and easy to do, but it doesn't really scale to the kinds of tasks that we're talking about. So we were thinking about what kind of use cases the manifest editor might help us solve. Could we provide quick and powerful ways to work directly with machine learning models, maybe integrate them with our cloud services platform? And the kinds of use cases we're thinking about are the individual researcher who might be doing transcription, they might be describing objects, classifying objects, and so on. But then also technologists, archivists, librarians, and so on, who are more interested in assessing what kinds of models will work well with their content. So they have content, they're pretty sure that it's amenable to some kind of machine enrichment or description, but they're not sure which model is going to work and what kind of things are going to be successful. So can we provide some tooling that can help with that process? But also, a lot of objects are complex objects. There are some pages that are easy to OCR, some pages that have lots of marginalia or are handwritten or complex in some other way. So can we do some kind of smart enrichment where the tool itself helps you choose the right model for the right canvas? And can we do kind of bulk processing of larger items or collections like manifests and collections of manifests? So starting with classification, what we did is we trained a very small, lightweight kind of classifier model that will look at a manifest. In this case, it's a set of samples of different pages from Leeds special collection objects. Some are printed, some are handwritten. I can click here in the top right and classify these by OCR difficulty, and it runs a model in the browser, so nothing's been sent to the cloud, it's just being done on your machine. It runs pretty quickly. Some of these videos have been sped up slightly, but in this case not, because it's a tiny model. So it's just working out, is this easy or hard? And I'll show you later how that can then be used to make some choices inside the manifest editor. So I've got this initial classification, and I want to test some single local model. Again, much like the classifier, one that's going to run in the manifest editor in your browser rather than anywhere in the cloud. So in this example, I'm picking one of the easier frames. So you can see that I'm flicking through the manifest. Some of these are quite challenging. There's some early printed books, modern handwritten material, an older book, but not early printed book. So this is a thesis. So I'm going to run a local OCR. In this case, it's with Dockling, which is running in my browser, not in the cloud. And it takes a couple of seconds. It's not the quickest. But I've got some text here. And you can see I've got a block of text. It's not segmented it, but the text is more or less okay. I'm going to have a look at this in our Theseus viewer. So you can do kind of round tripping between the manifest editor and an external viewer, not just Theseus, but other standard IIIF viewers. So once I've created these annotations using some model, I can throw it out into a viewer and see how it looks and how it renders it. You can see in this case, this Dockling model doesn't do line-by-line segmentation. It's much more kind of layout-based. But the text that is generated here is reasonably okay, but there are some mistakes. I can see things like it says a study of nucleic actids, which is nucleic acids and so on. So it's not quite perfect. So this time, I've done that initial assessment. I might want then to rerun this with a local remote model. So I'd run it with a remote model. So now sending it out to a cloud service using a larger model. So this is exactly the same process, but this time I can run remote OCR rather than cloud OCR, choose a model. In this case, it's a small one, and then run that and get some results. It's now sending it off to a cloud service. And you can see we've got more segmentation, 3 blocks, but there's some markdown in here because the model that we've used will provide some markdown information. But I can then use this to evaluate, okay, can I do this with my local in-browser model or something bigger? So what the remote inference service on the back end is handling is kind of efficient extraction of IIIF image API resources to hand off to some cloud provider to run the inference. It has a registry of models, which is extensible and kind of modular, and it knows how to invoke a particular model for a particular task, whether that's OCR or structured data extraction and so on. It has quite a lot of tooling and guardrails around parsing those outputs, making sure we're getting back valid JSON, and then normalizing those. Lots of different kind of visual language models, as I think some people in the room will have experimented with. Return coordinates in different coordinate spaces. It might be a floating point number less than 1. It might be normalized to a 1,000 by 1,000 box. It might be normalized to whatever size the image was that we sent to them, but not to the canvas dimensions. So there's normalization happening that's transforming it back into IIIF annotations that target the coordinate space of the canvas and doing any kind of text and markdown processing. And all of that's turned back into IIIF presentation API and annotation content. So it's really a kind of middleware layer that's just handling that normalization on the way through. It's not doing any real inference on that service. So this time I've looked at my manifest. I've tried a couple of different models. I want to try a slightly more challenging canvas. So within this sample manifest, we've got this engraved piece of text. I'm going to send this out to a larger, in this case, Qwen 9 billion parameter model. And what I get back is quite a lot better than you would get if you used a smaller model. So the segmentation is quite well aligned with the text on the image, and the text quality is pretty good. But it's picked up some stuff that I don't actually want, like these handwritten annotations. And because this is the manifest editor, I can just delete these. So that sort of nice user-friendly integration between the content. And also there's a kerning issue here, so it's added a space. So I've just gone in and edited the name of the watch clock maker to remove that space in Ascrig. So we're able to use the kind of round tripping between the manifest editor or some external inference provider and then the editing to then get back to something that's a kind of cleaner output. So individual research kind of use case, this kind of tooling is a nice user-friendly way to work with these kind of models. With a more challenging example here, this is Charlotte Bronte's handwriting. So I'm going to run a larger model, again, the same 9 billion parameter model, so nothing crazy. And in this case, you can see that the segmentation is line by line, and the quality is good. It's pretty much bang on. And I can then take this out, cast it off to the Theseus viewer, and then see the thing in the context of a IIIF viewer. So you can see here now, I'm viewing the annotations with bounding boxes. I could have edited the text in the manifest editor if they'd been incorrect. So again, we're thinking about how does the kind of user-friendliness of a tool like this give you an on-ramp to testing out and playing with and experimenting with models without having to write any integrations yourself. We can also do structured data extraction. So the same letter, this is another page in the same letter. Maybe I want to extract the addressee and the date information. So we've got some simple web form interface here where I can add fields that I want to extract and then run it. And again, it's trying to sort of provide a sort of scaffolding around this, some guardrails to try and pull back structured data. So we've got the date of writing, April 6th, the addressee, Amelia, the place, which is actually wrong because it's not Hanworth, it's Haworth, I believe. But it's done a pretty good job of extracting that structured data. I could do a slightly more complex case. This is the frontispiece of a book. This time I'm going to type in all the fields that I want. So I want the date of publication, and I want it in some kind of modern date format. I didn't specify ISO, whatever. I want the author name, title, and subtitle, and I wanted to split the title and subtitle. So I can give it a description. We've all seen a lot of this being done using kind of chatbots and uploading images, but in this case, we've got round-tripping from the manifest editor out to the model, and I get the data back, and I get the structured data back. It returns both JSON and HTML, and I can see that the subtitle here is huge, but it has actually done a good job of getting it correctly. So, this is the kind of individual researcher kind of use case, but also the technologist or the archivist of a librarian who wants to evaluate how well different approaches work on their material. But you can also process larger numbers of things using kind of guided processing. So we ran that classifier earlier. We know which things are easy, which things are hard. So this is a slightly sped up video, but I'm just telling it to run a small model on the things that it classified as being of medium difficulty. And it has some queuing in the manifest editor, and it will just process all of the images that are assessed as medium difficulty with one model. And I could send all the things that are of hard difficulty to another model. So you can use that kind of guidance to give you a bit of choice and bulk processing. This would work on a really big manifest. The manifest editor itself is maintaining the queues. So you can see here, we've got a printed book, early-ish printed book. And again, there's some mistakes in here, but the text quality is pretty good. I only used a very small model for doing this. So the kind of current status, a lot of this is being built to be integrated with cloud services. So the things that can provide on top of this are storage and preservation of these machine learning outputs, access to remote inference models, things that run in the cloud, things that cost us, so there's actually an inference cost, and a wider range of models, being able to offload bulk processing. Obviously the manifest editor handles queuing quite well, but it's not going to work if you've got like 100,000 items that you want to do. It's not really what it's designed for. And also dedicated inference provision. So for the examples you've seen already, it's using shared inference, but if you had to spin up dedicated provision for a particular model, for a particular scale of processing, that could be handled in that way. So where we are right now, we're doing UX and usability testing with this version of the manifest editor with cloud services users. Testing of the manifest editor with enrichment doesn't require a cloud services account because you can test it with just local models in your browser. So if you want to test it, want to play around with the, doing the classification and the initial enrichment, then talk to me or email me, matt.mcgrattan@digirati.com, or just grab us at some point during the conference, and we can hook you up with access to kind of preview of the manifest editor, and you can try that out. So that's everything from me. Thank you.
Hello everyone, my name is Linnéa and I work at the Swedish National Archives, and I work with all kinds of digital access to the archival collections. Today I will speak to you about the different actions that we are taking to make the archives more accessible. We provide digital access in different ways. We have our online search service, the National Archives database, and it gives access to 250,000 fonts and 73 million images of archival documents. We have open APIs for archival metadata and images, several open data sets, and we also make some of our content available in the Wikimedia projects. But still, even if we do all this, it is still quite hard to use the archives. The searchable metadata is often very minimal. The images, they show documents of text, but they are not searchable text themselves. And researching large amounts of archival material is very time-consuming. And also the old handwriting is very hard to read, at least for someone like me that is not trained on that. So we want to do something about this. Our goal is now to do several different activities and new developments to try to make this situation better. We are taking actions to help users read the old Swedish handwriting. We are making the content of the documents machine readable and searchable. And we are making it possible to use both through our user interface and also through our open APIs. And this also opens up for us ourselves to start experimenting with new AI functionality to assist users in researching the archives. So in 2024, we started a project to integrate the ongoing developments of handwritten text recognition into our search service, image viewer, and the APIs. But a lot of work, of course, came before this. Much time has been put into exploring HTR and AI in archives and making this infrastructure that we can use now. We have also been running several community projects with volunteers and genealogists to get training data for our HTR models. But we are going to talk a bit about the last things on this timeline. And just really quick about the HTR base model that we are using right now. This is the result of our HTR and AI development. We call this model the Swedish Lion, and it is on average 95% accurate. It is best on 19th century handwriting, reflecting, of course, the available training data. And the model is trained on data from different sources, not only our own community projects. And we also put the Swedish Lion into use with our own software for production scale document processing, HTR Flow. And both the HTR Flow and the Swedish Lion is open source. So, as I said, in 2024, we started this project of making the archives more accessible with HTR. And the first release of searchable documents we made in April 2025, and that was mostly made up of documents from the Svea Court of Appeal, and also some archival documents related to the witch processes in Sweden. So this release was about 1.2 million images that were made searchable with this release. And since then, we have published searchable text for another 2 million documents. And this is all running text because this is what the Swedish Lion is best at. and it's a lot of legal documents and protocols and things like that. And we plan to add text to another 750,000 images after the summer. And we also plan to update the Swedish Lion and also reprocess all the already published images with the new version of the Swedish Lion. So we are continuously trying to make the model better. So how did we do this then? The process involves, of course, then processing the images with AI and HTR. And this results in a lot of auto files, auto XML files, and they are stored with the images at our image storage. And then the records management database is updated with information that there is an auto file present for that specific image. And the auto files are indexed together with the archival metadata in Solar Cloud. And this is using the Solar OCR highlighting plugin. And then we use the IIIF content search to enable search within the images and the archival files. And this is also me trying to visualize this process. So this is basically the same that I just said, where the gray top boxes are the internal steps with the HTR processing, storing the auto XML files, updating the archival database, and indexing it in Solar. And then we are doing all kinds of external publication of the result. So we are publishing the result in our National Archives database. We are using the Universal Viewer as our image viewer. And we are using the IIIF Content Search API, as I said, and also, of course, the image and the presentation API. And we are also making all the HTR text available in our REST API. That is also an open API. So, and this API corresponds regarding the functionality largely to what you can find in the National Archives database. So if the National Archives database is the user interface, the REST API is the same, but for machines. And we are also ourselves putting this infrastructure of publication into use by actually experimenting with our own MCP server. But first, let's have a look at the image viewer, because in this project we did a lot of development actually to the universal viewer to make it possible to search and view the handwritten text recognition text inside the viewer. So we have an added functionality for searching and viewing the text. We have this search panel that displays text snippets from within the document. And we have a text panel that displays the full HTR processed text right next to the image. And this highlighting function that highlights the searched word both in the image and also in the text. And all the development that we have made to the universal viewer is in the annotations branch in UV4 GitHub repository. And hopefully we can, when the time is right, together with the community, make this development a part of the universal viewer. And we also made some alterations to the National Archives database. Actually not that big of a development in our open search service, and that is because we are actually redesigning the whole National Archives database. So we didn't want to put too much of an effort into making new development in the old version of the database. But we have made this checkbox that makes the choice to search all the transcribed text that is published up until today. So if you check this box, it searches through all the text that is present, so all these millions of pages. And the result is it's all the files, and you get 3 snippets that shows you a preview. So this is it in action. You check the box and search for something. In this case, I search for a Swedish last name of a famous person that is from my hometown. And I get some results, and this is the files, archival files, as I said, and yeah, let's open the viewer. So this is the redesigned universal viewer with the search results right there, and that's the search results within this archival file, of course. And you can see the searched words in the image. You can see the full text of this specific image that we are looking at in the text panel, and I can also click both in the text or in the image to highlight a specific row here. Yes. And what we also added is 2 metadata fields in the more information panel that tells the user that this text is made with AI and that it can contain errors, of course. And we also have a quality prediction number that is actually not very accurate, but we are working on well, it's like a measurement of the AI model, how sure it is of itself, and it's very sure of itself all the time. So it's not like we are currently actually developing a new measurement, and we are going to change this one to the new one, so it's more accurate. Yes, and as I said, we are developing a new user interface for our online search service. The old one is quite outdated, as you can see. So we are also hoping that this will make our search service much more user-friendly, and it will also follow accessibility guidelines and yeah, making it much easier to use the archives, hopefully. So a quick look at our APIs then, and how we are making the HTR process text available. Before this project that we started in 2024, our open REST API already gave access to archival metadata and links to the images in IIIF. But in this project, we added the possibility to search through all HTR process text as well. And as I said, the functionality corresponds to this checkbox in the user interface. Yeah. And a quick look at what my ML engineer colleagues are working on right now. We are hopefully making it even easier to access the information in the archives. We are building an MCP server, and it uses our REST API and our IIIF API and fetches the information directly from the source. And it also includes tools that can show you the images and transcribe handwriting on demand in your AI agent of your choice. So you can use it with Claude, ChatGPT, LeChat from Mistral, or whatever you like. And just a quick look at what it does. So you can be like very unspecific and ask anything. And in this question, I am asking about divorces in historical documents in Sweden. And it's a very unspecific question. The MCP gives me some examples. And it also gives me the sources. And I didn't ask Claude to specifically use our MCP, but it does anyway. It like knows by my question that this is the MCP that it is supposed to use. And here you can see the sources in the archives. I'm not sure why it switched to Swedish, because I did ask the question in English, but I guess I guess it knows that I usually talk to it in Swedish, so we switched back and forth here in Swedish and English. And yeah, so I also asked, well, this sounds interesting, one of the examples. Can you show me the exact page in the archive of this specific case? And now it is working really hard to find the page, but it pops up right in my Claude client here, the correct archival document. And it also transcribes it for me to modern Swedish, which is great, because I'm not very good at historical Swedish. Yeah. So this is a tool that is absolutely great for someone like me that is not an archivist or a historian. So this makes the archives much easier to use for me and hopefully for many others. And that is what we are trying to do with all of these initiatives. The HTR makes the handwritten text machine readable. We're making a new interface for our online search service to make it more easy, more accessible. And we are developing these APIs to make data-driven use possible. And we are also ourselves trying to use these new interfaces to do pilots of new and exciting development. And this is, of course, only possible because we are using open standards and APIs like the IIIF.
Thanks, Glenn. So, good morning. I'm Sara Brumfeld. I'm here with Ben. Together, we're FromthePage, a crowdsourced manuscript transcription platform. But really, the AI people would call us a human-in-the-loop platform. But since we're on Team Human, we kind of prefer to think of it as an AI-in-the-loop sort of platform. We've been working with the IIIF standard for a decade now. This is actually a really early slide of some of the many institutions that had pulled information into items from the page for transcription. But today, what we're going to talk about is how we're using the Google Gemini 3 APIs for transcription with those IIIF images. So we're sending them, we're getting responses, how we're storing them and showing them to transcribers, and then displaying and using that in our user interface, and then how we expose everything that we know in a IIIF manifest. So in November, it was a Saturday, I was drinking my coffee, and Ben sends me this newsletter. He's like, you should probably read this. Okay, we run a crowdsourcing platform that does transcription. And this basically said, yeah, Google screwed this out. You don't have to do transcription anymore. So I had about a 5-minute existential crisis, and then I'm like, maybe we should just build this in. So why now? Why Gemini 3? We've actually been experimenting with lots of different solutions for handwritten text recognition for about 3 years. And the only one that we'd ever built in before was Transcribus, and in a slightly different way than we've done with this. And the reason we built in Gemini 3 is it's very good at historical document transcription. Mark Humphreys, as he wrote that first newsletter, this is a follow-up, and in the experiments he ran with it, he saw a character error rate of 1.7%, a word error rate of 6.5%. That's very, very good. We're seeing a lot more variation because we have a lot of variant texts, but still, it's very good. But more importantly than that, for us, it's about trustworthiness. So this is, again, Mark Humphreys, but he's like, it doesn't hallucinate. The errors that we've seen in the many, many experiments that people on FromthePage have run, it makes the same types of mistakes that humans make. And if we are going to produce text that you are going to pull into your library systems, we can't have poison pills, right? We cannot have text that hallucinates and makes things up. So only because it was willing to do things like unclear or ink blot, just like a human would, were we willing to pull it in for volunteer transcribers to use this text.
So let's take a look at some code. How do we actually do this? So sending IIIF images to the Gemini API is something that will make anyone in this room cringe, because rather than passing a lovely URL to a IIIF image service, you have to download the image, bundle it up, and push it to Gemini. Boo. It's what we're stuck with right now. Okay, you get a response back. The response has candidates that have a number of parts in them. In this case, we're asking for a transcription, and we get both reasoning and we get the thoughts. We also get some metadata about the tokens it used in the model that was being used. So once we have that, we can actually store that and present it. So we've added a new AI tab to every page on FromthePage that has these Gemini texts available. And the most important thing there is the provenance. We say exactly what model this was run with and when it was run, because as we all know, these things can change over time, and sometimes the results you get on Tuesday are better than the results you get on Friday when the model is tired for some reason. We also display the prompt, right? Here is the prompt that was used to generate this. A lot of this was informed by the provenance ontology. We want to expose as much as we possibly can.
We also grab that token usage from the API response, and this for us is a proxy and a way to start slowly addressing well, how much energy does this use? How bad is this for the environment? So you can see it for every page, and then you can see it for an entire collection. There are tools out there like John Ippolito at University of Maine has a what uses more tool that actually uses token count as a proxy for you to compare this to, say downloading and watching your Netflix movie, which also uses a lot of energy.
We also pull reasoning. So reasoning is a byproduct of these chain of thought models. And the reasoning results are sometimes very entertaining to read. And I can tell you stories of ridiculous rabbit holes things go down. But one of the things that's really interesting, Mark Humphreys describes these as seeming to have a model of reality. I prefer Ted Underwood's description of these as being a model of culture. And we start to see that in examples like this, in which we're just handing it an image from Queen's University Archives saying, here's a historic thing, transcribe this, right?
Nothing special in this prompt.
Nothing special. What we're seeing is, if you look at the bottom, hey, I see names like Gervais and Toussaint-Laplante and Fish Creek and Batoche. This suggests the Northwest Rebellion of 1885. So it's able to use that historic context to continue transcribing the information that it finds in this image.
And what we often see is it goes back and then comes forward and then goes back and comes forward. And then it's like, okay, I think I'm done.
And that's what you'd want from a human transcriber. Right, so how do we actually integrate it into the human side of things? So if this has been provided to people using a collection, and
institutions get to decide.
Yeah.
Like, we are not going to run AI on
Right.
stuff if you don't say.
Then a volunteer who's transcribing, this is our straightforward transcription interface, can click a new AI draft button. That pre-populates the transcription window with what we got back from Gemini and prepends a warning onto that saying, hey, this probably has errors. Please correct this. What we find is that for crowdsourcing projects that have enabled Google Gemini, about half their volunteers use it and about half don't. Great.
It's fine. We don't care. When you click that button, we also we log it. So this is what we call our deeds list that's public to anyone who can work on the project. And if you kind of look, the second and the fourth are AI draft used. So anyone can see that an AI draft was used. And then as you save versions, our version screen has a cute little robot icon next to the version that you used an AI draft for. So we're trying to make this as transparent as possible.
And that means that even if things have been transcribed and checked by humans, we want to attach the note, hey, an LLM was involved in this process here somewhere.
Right.
Okay, if this has been corrected by a human, or perhaps the AI draft was run after humans corrected this, we have
Humans transcribe this.
Transcribe this, right. We have the ability to compare the AI draft against the human crown truth. This is pretty typical of what we'll see for documents. You know, we have some errors that are legitimate misreadings and others that are really stylistic choices, about 50-50 so far.
And often it's a lot better than this,
Yeah.
even.
Having that ground truth means that we can calculate character error rates. We do this in two different ways. One comparing the verbatim output, and another just removing all the formatting and white space and comparing texts. This also gives us access to measures like non-stop word accuracy. We tend to see really pretty impressive results in this, but again, it varies
You have
on
to
the
explain what that is.
information. Non-stop, yeah, take out all the of the things like that.
Just the important words are left.
Important words
Right.
are left, yeah.
We're a platform that work happens on, and then we provide a lot of different export formats for you to pull things out, including IIIF. But this UI is the only one that kind of captures the changes that we've made, which is when you do an export, you can choose to only send human-edited transcripts, or you can send human-edited transcripts when they're available. Otherwise, you can send AI drafts, so both. You can, in this case, this is a push-to-content DM using their Catcher API. Which field do you send the transcript to? Do you want to include the AI provenance, the model and the date? And if you do, what field does it go into? And do you want to prepend a warning, this transcript is AI generated? And we're sticking these at the top of the transcript, which is a terrible place to put them, but that's the only place they show up in many user interfaces. We got a whole birds of a feather about this sort of thing on Thursday, so come to that.
Okay, so how are we actually exposing all this provenance information in our APIs? So we give some pretty raw data in the see also stanza for every canvas, including both the AI-generated transcript in plain text with the model next to it and the reasoning explanation. Again, we want to expose as much as possible. In annotations, what we've done is we've added a generator and generated set of stanzas. We're, again, kind of going back and forth. We'll be talking about this in the birds of the feather. Lots of viewers don't actually display this. So when you drop a FromthePage manifest into Mirador, in this case, we will actually show warnings if something is AI generated. Again, we'll prepend that to the very top of the annotation text so that you're always going to see it. And again, in our IIIF manifests, if there is human work available, we send that instead of showing the AI annotation. We just don't show the AI outputs at all in that case. So what are the results? So far, we've seen project owners run something like, I want to say 10% of the pages in FromthePage through AI drafts. So
That's
this is
10% of 2 million pages.
10% of 4.5 million pages. So yeah, so that's a lot. And one of the things that we saw, we actually got this email last night. We were doing some analysis for the Los Angeles County Public Library. They've been running crowdsourcing projects on FromthePage for 10 years now, actually. And what they saw is that their productivity tripled once they added the AI draft feature. The thing I think is really cool is that the people who aren't using AI drafts at all, for some reason, their productivity is up 50%. Right? So again, we've got a couple of quotes from Daniel Guerrero saying the project did the same volume of work in 16 weeks as it had in the previous 47. So again, same output and a third of the time. One of the other things that's really interesting is that all of these human transcripts are reviewed by a staff member, and the staff member says that it's taking less time to review because the results are more accurate and there's less correction that she has to make. So that's pretty cool.
And if you want to have a fun hallway conversation, we have lots of ideas about how to speed up review using AI as well. So if you want more, we did a community call a couple months ago. This QR code will link you out to that YouTube video. And it covers entirely different stuff, like Gemini loves typesetting, some of the reasoning craziness, where we do see misreadings and some mistakes, and kind of our prompt iteration process. You can also do a trial on FromthePage, and we'll run this on 200 pages for you. So, and you can just go sign up and do that on your own. We're also, more than happy to talk ad nauseum about everything that we've done here.
Hi, everybody. My name is Marlo Longley. I'm a software developer at Stanford Libraries, where I'm also a contributor to the open source Mirador IIIF viewer. I helped organize the most recent release of Mirador, and so my presentation today is based on that experience. Today, I'll share some background about Mirador and the current software release. After that, I'll talk about Mirador plugins, which are a powerful way to extend the viewer to meet specific research and institutional needs. I'll share a few example plugins, as well as some of the challenges that come with supporting the software behind them. And finally, I'll give a preview of where the project may be headed next. All right, so many of you will be familiar with the Mirador viewer. It was first built in 2013, which makes it something of a veteran in the IIIF landscape. Mirador version 4 was released in October 2025. So over the past 13 years, we've now seen 4 major releases of the software. Mirador 4 represented a renewed commitment to the Mirador project. It was built with the help of our dedicated international community and, of course, the contributors to previous versions of the software. And prior to this effort, it had been several years since a Mirador release. Unlike earlier versions that introduced visible user features, Mirador 4 was primarily an investment in software sustainability and modernization. The goal was to make the code base more resilient and easy to work with. It was a substantial effort that aligned the project with current versions of front-end frameworks and development tooling, made significant gains in accessibility and language translation, and improved the developer experience by simplifying and documenting our public extension points. So this release was not visually flashy, but it's work that allows Mirador to remain a platform that institutions can build on in the coming years. So reflecting on this timeline, it's clear that the IIIF landscape has changed a lot during the period since 2013. IIIF adoption has greatly increased, and viewer technology has changed. Many IIIF viewers now exist alongside Mirador. Some focus on certain material types, while others integrate with specific technology stacks, and they all have different strengths and purposes. In this environment, I've started to realize that one of Mirador's most distinctive qualities is the ability to extend and customize the viewer. When I saw that 2 other presentations at this conference will be showcasing custom Mirador plugins, it only confirmed this idea for me, and I'll mention those in a later slide. So to understand how extension works, it helps to look at the underlying architecture. Mirador was intentionally designed so that institutions can adapt the viewer to local needs without forking the code base. Plugins can add new panels and views, respond to internal viewer events such as opening a menu, and also zooming in on an image or loading a manifest. Under the hood, Mirador runs on React, so we use the Redux library, which is a tool that integrates with React. It dispatches events to drive the internal application state, and within Mirador, these events are triggered continuously throughout user interactions and content loading. So historically, the architectural principle within Mirador has been to allow complete access to all these internal events in the internal application state. It's basically built to be plugged into. And all of Mirador's React components can also be imported by plugin authors. It's worth noting that there are also many configuration options that can adjust the user interface, such as changing to a dark theme color. And so these settings allow for customization options without even needing to consider writing a plugin. But the underlying openness to Mirador's structure is powerful for developers, and it allows people to imagine their own ideas and use Mirador as a platform. Overall, this flexibility has enabled institutions to build specialized interfaces on top of a shared open source foundation. So I'd like to cite a few examples of community plugins to ground what I'm talking about. Pictured in this slide on the left, we see work from Harvard Libraries. They created a Mirador plugin to display poetic line breaks in the Emily Dickinson archive. And on the right of this slide, we see the Archiox plugin from the Bodleian Library, which allows users to adjust lighting in order to inspect copper plates from the 1700s. Also, as I mentioned previously, several talks at this conference will showcase Mirador plugins. Coming up, we'll hear from the CRC in France about their plugin for scientific imaging, which displays chemical analysis of digitized material. And later today, we'll also hear from Leiden University about a semantic search plugin for Mirador. So we can see that the same viewer is being extended for very diverse scholarly purposes across an international group. There are also several core plugins maintained by the Mirador community, an image tool plugin for adjusting color, saturation, and other image properties, and also a sharing plugin and a download plugin. So looking across these examples, what sticks out to me as a maintainer is that institutions are using Mirador less as a fixed product and more as a framework for building domain-specific research interfaces. I want to share just one lightweight example from Stanford that shows a different type of plugin. In this case, the extension is not supporting new features or UI elements, but giving us insight into how IIIF collections are used and into Mirador itself. This is just a small plugin we use in production that listens to Mirador events and sends them to Google Analytics. Compared to the more complex research-oriented plugins I just showed, this one is very small. It's just a few hundred lines of code, and it doesn't change the interface at all. But because the events we capture include IIIF context, such as the manifest or the Canvas index, they're richer than standard Google Analytics events. This gives us a way to understand what objects are being accessed, and it also helps surface how Mirador itself is being used, and in turn, inform how it might evolve in the future. We're still exploring this data, but we see differences in engagement patterns across collections. Some objects lead users to multiple viewer tools and navigation features, while others are primarily accessed in a direct viewing mode with minimal interaction. This suggests that a single set of interface defaults may not be appropriate for all types of content. So even at a very low technical cost, this plugin provides value for both collection insight and Mirador user research. I wanted to share just at least one finding from those analytics. I looked into our data from the past few weeks to prepare for this talk, and I found that digitized Stanford yearbooks were very popular, and they were some of our most heavily viewed content. And I'm guessing that could be because of graduation season and reunion season. But I found that users were registering hundreds of paging events in the yearbooks. This was by far our most intensely navigated content. So that's interesting from a collection standpoint for the university archives, but it also raises questions about whether users are enjoying clicking hundreds of times, or whether there is an interface choice that could be better for long books. So these yearbooks are around 450 pages, and the analytics data was showing people clicking through the majority of the pages. So this is just one small example of a plugin and a finding, but it demonstrates the power of being able to plug into Mirador events. So now that we've looked at several plugins, I'll just turn to what's next for the project. My institution, Stanford University Libraries, is investing resources into Mirador in the form of developer time, product mapping, and user research. This summer, we're focused on technical planning and issue triage, and work from a group of Stanford developers is planned for late 2026 and early 2027. We will continue to update core dependencies like React and OpenSeaDragon. As far as the IIIF spec, one priority is implementing the Authentication 2 framework. That's needed internally at Stanford for serving our media content, and that work is scheduled and planned for inclusion in Mirador. But as we've seen throughout this talk, Mirador's open architecture has helped it grow as a highly customizable viewer. That also presents some challenges as far as maintaining the code and providing a good developer experience. So in some ways, total openness carries a risk of becoming overwhelming. The goal for developers is to be able to extend Mirador without needing deep knowledge of its internal structure. And so that means continuing to work toward cleaner APIs and better documentation. And clarifying these patterns is a development priority for the upcoming work on my team. So today, extension patterns are organized around the internal architecture, not around the types of things developers are actually trying to do. So going forward, we're shifting toward intuitive concepts such as adding a menu, responding to an event, or integrating an external service. The goal is to make common patterns easier without limiting experimentation or openness. So yeah, this is my chance to say to all of you, if you have ideas about what APIs should look like, or if you've run up against difficulties trying to extend Mirador, we really want to hear from you. And feedback from plugin authors is already shaping our upcoming roadmap. And even if you just have an idea for a plugin or you're not sure how to proceed with that, it helps us to understand community needs. So that's the end of the talk, but to reiterate, if you're experimenting with new research interfaces or have questions, we'd really love to hear from you. Our community is active and international. Everyone is welcome at our bi-weekly meetings. Developers, along with people working on UX, accessibility, and specific research projects. Brittany LaPierre from the Canadian Research Knowledge Network, who we heard from in the opening talk, she, I guess, helped develop the idea box concept. She leads the Friday calls, and that's a great group to get connected with if you're an implementer. Yeah, so that's it for me. I'm really happy to be here, and hopefully we can chat more about Mirador. Thank you.
Thanks again for all our speakers. And could I have the speakers step over here? So Linnéa, Ben and Sara and Matt, and we'll be taking questions. And then you can carefully step up to the stage without tripping to answer your questions. So do we have any questions for this set of speakers? Over here.
Thanks, everyone. What a lot to take in, and some nice weaving thoughts and themes. For the Swedish National Library and for FromthePage, you're both using AI in this connect with others, but largely hosted online AI. Any thoughts about running locally, including the Gemma engine from Google, and maybe being able to have self-contained, or even to be able to scale between local and remote?
We are running local. Sorry, I didn't say that, but it is our own infrastructure. We have our own AI infrastructure, so it is all local.
Yeah, so that's your Lion engine, is that right?
What?
The name of your AI?
Yeah, Swedish Lion, exactly,
yeah.
and the HTR flow. So it's all local on local machines, nothing in the cloud or in any of the...
Sorry, maybe I was confused because you were talking about Claude and other engines being used as well. If it's all done by Swedish Lion, great to know.
Yeah. Yes, at this point it is all done by the Swedish Lion, so we have full control. But the MCP, of course, connects to your AI model of choice, but that's the user interface. And what we are doing internally is all in-house. Okay.
Thanks so much.
Thanks.
I can speak briefly to what we're doing. So for us, at least, there is a quality threshold below which we are not going to integrate anything. All right, and that quality threshold is not like a character error rate number. It is, again, does the engine make transcription errors that are more plausible than the original, which is what all these hallucinations are, right? You cannot spot check something like that. Once a local model comes out that doesn't have that hallucination problem, we would be interested. But right now, there's only one engine that we trust not to do that.
Sorry, and particularly it's a fairly recent development. Gemma is the Gemini engine that can be run locally. Now that may be so new that we have to test it out, but that's a hopeful thing.
We will have to test it out. We have found that Gemini Flash and other things don't have the same standards that we need. So we're suspicious until verified.
Hi, thanks so much for the presentations. I have a Swedish Lion question as well. I'm really interested in your sort of predictability, your accuracy scoring.
Yes.
And you said, obviously, ethics is doing a really good job, so yeah, that makes sense. Could you speak a little bit more about how you're going to potentially get that to work more accurately? Are you thinking about another model checking the model's work, like model as evaluator? And yeah, just interested to see about your thoughts about exposing that and using it.
Unfortunately, I'm not the right person to ask this question to. It should be one of my data scientist colleagues who are working with this. I don't know, David, do you know what Eric is working on the new prediction? Yes, you can talk to David later. Okay, I'm sorry, I'm not the right person.
So yes, we are. I mean, in practice, so the current Swedish Lion uses TR-OCR, but a transformers-based OCR engine as its architecture. We are giving it more training data. That's one way to improve it. We are developing a model called a quality prediction model to give the more accurate quality assessments that Linnéa spoke about. Currently, we're not doing any post-processing of the output from the model. That could be something that you may want to do. We've done some experiments using and many other teams, what's it called? Post-OCR, LLM correction, I think you say in English. The concern would be that they overcorrect things. Yeah, we'll see. We have decided basically, though, that it's better to provide our users with texts, even if flawed, than not to provide them at all, which is the other option.
Hi. Yeah, thank you very much for the great presentations. I have a question which is perhaps for all of you except Marlo. I'm sorry, because it's about the data, metadata representation for all those transcriptions and enrichments. The presentation from the page highlighted the problem with showing warnings, and there's the provenance, which I understand is accessible via C also, plus some profile. I'm sorry, I did not get it, because that was very quick. But I wanted to get a feeling from the three presentations who worked on those aspects. Like, would you need something? Did you feel a need for a more standard pattern or even extension in the API spec so that these kind of functions would be better supported? I guess I'm kind of asking with one specific perspective, but I'm genuinely curious to hear from you.
Right. I think, one of the problems we always run into in IIIF is you want the viewers to show the right thing, and the viewers haven't necessarily caught up unless you're, running the viewer and modifying the viewer. So we are just kind of shoving things everywhere right now. But part of the Birds of a Feather session that we and a number of other people in this room are hosting tomorrow, Thursday, is to try to have those discussions and try to come up with cookbook recipes is kind of where we think it needs to fall. If we write some cookbook recipes, then hopefully the viewers will adopt them, and we have a nice ecosystem of IIIF.
Quite similar. I mean, we've used the same web annotation property, like the sort of generated information on crowdsourcing projects and elsewhere to store provenance information. We are getting that information back as part of the payload that the manifest editor has. We're just not putting it anywhere yet. So I think that would be part of that discussion, would be where does it go? Because we certainly have it in the kind of underlying data that's passed around. We're just not surfacing it. So I think that conversation would be a good conversation to have, I think.
I have a related question, I guess, to that, because I heard mentioned that on the transcriptions that are AI generated, that the viewers should have a way of disclaiming that they're AI generated. But I'd argue that the opposite's maybe also more important, that we should be highlighting when a human has been doing it in the same way. Then I think that's for the viewers as well. They should be highlighting that so that people, because I think over time people are going to be expecting that a lot of this is AI generated or machine generated, and they might appreciate or trust it more in the other direction as well. I'm just curious if there's been any.
Okay, I can say something. The field that we are using, we call it transcription method. So we are showing both if it is AI, HTR, or if it is a human that has done the transcription. So you can see it there. Because we also make all our ground truth data available instead. When there is ground truth data, we do not publish the HTR.
Thank you for the great presentation. I have a question, I believe, for Sara. Because you were mentioning about the existing crisis. Like, I definitely have that moment for like a week. I feel like I don't know what to do. So I know we're all talking about preparing for the next year or so. Like, what are the things you feel like the AI can help us more? What are the things like is more like human that we should do? And I think that also go a little bit with the Swedish archive. You're designing the UI. Are we thinking about agent-to-agent interface, or is still human?
The thing I'm most excited about is the physical world and the machine, and where we can kind of look at where those things intersect, which is not, we've always worked digital, and like IIIF, we kind of post-digitization, but I think what happens when you start working backwards in that workflow? And I think we have some tools to do some of that now, which I'm kind of excited about. And then kind of, I don't know, the existential crisis, it's not just, it's everybody in this room, right? And like, we had it for transcription. Our volunteer, we got an email from a volunteer and we announced this, she's like, what's my purpose, right? She's somebody who's super volunteer, does a ton of stuff. I'm like, just try it out, see what you think. And she went to her local history society and convinced them to upload some financial records. This is not stuff anyone really wants to transcribe. Financial records are hard. And she came back 2 weeks later and she's like, I don't think I'll ever do this again without an AI draft. We're like, okay. So like, I think we just have to sit with that discomfort and figure out where and how we as humans are going to choose to use it. I know we're using it for software development all over the place, and it's made it more fun, again, which is kind of fun.
Hello, my name is Marlo, and I'm from the Amsterdam City Archives, and I have a question for Linnéa. I really recognize your ambitions, it completely aligns with our ambitions. But what we see is a very strange paradox. You want to make things simpler for the audience, but when we do user testing, they say it gets more complicated. And I was wondering what your experience is in that. How do you have the same responses? And if yes, how do you deal with that?
Well, I'm not sure. Are you thinking about the MCP or anything specific? No, just in general, harder?
Well, specifically the introduction of transcripts, so searching through metadata and through the content in transcripts.
Yes, we have had some of that kind of reactions from really hardcore genealogists.
Exactly.
Yeah, and they are of this. They are thinking like that. I don't know, but for everyone else that is not a hardcore, really know how to read the handwriting, I think we have had a lot of positive reactions, at least from what we have heard, and also on the MCP, a lot of positive reactions, and there we are now starting beta testing with real researchers, and we are hoping to interview them and do like more test if it is good, because now it's just us who has tested it at this point. So, but yeah, I recognize this reaction.
Yeah, thank you.
Any other questions for our panel this time?
Hello. I actually have one more question regarding the MCP server, because I'm from National Library of Poland. We have been experimenting with MCP servers for some resources, and one thing that comes to my mind is the response time when the data set is larger. So you mentioned like a couple of millions of images. I'm not sure if it's single images or multi-page documents, but the use cases you've been testing so far, that means researching the text of a single document or the whole collection. How does it look like?
Yeah, it's the whole collection. So the MCP connects to all the transcribed texts, and it's several pages in the manifests, and all the data, metadata in the API. So right now, in this very early, beta version, it is quite slow, but we are, of course, gonna work on that also if we put it in production, if we release it. Yeah.
Hello, I have a question for everybody except Marlo, I think, again. Sorry. When you use the remote AI applications or these providers, and for example, if you're sending the image, of course, like with the IIIF manifest, or at least the image server, you can send a certain resolution and so forth. Have you experimented with different resolutions, like with 512 or 60 to 1256, or the full? I can imagine that the response might be different depending on the accuracy or the detail of the images.
Yes, we have, and in the manifest editor UI, you can select the resolution you want to send. So we have some sort of 4 options at the moment in there. I think for a lot of material, it doesn't seem to matter that much. Small images are fine, and it doesn't seem to make a huge difference to the quality of the text. For things with a lot of fine detail and handwritten material, larger images help, as long as you can kind of reconcile the coordinates coming back if you want to plot them on the image.
Yeah.
yeah, I think surprisingly small images still work quite well for a lot of text recognition. I think that would be one takeaway that we've had from experimenting.
So you were using local models as well, at least.
In the manifest editor, there is one local model, and there were 3 remote models set up. Okay. So with the remote model, the back-end middleware server is handling going and getting the IIIF, extracting the image data and sending it to the right place. So that's being handled kind of in middleware remotely. It doesn't seem to make a huge difference. Obviously, if someone's image servers are very slow, that might introduce a lag into the process.
That's exactly the question, especially also for the Gemini team, is that you would have to, I don't know if you like base 64 the image, you have to send a large image, you have to wait for the response to come back. So depending on the size of the image, also the inference, I mean, that would affect the user experience in that sense.
You run it all in the background. So you can click a button and it all happens queued up and happens in the background. So it's not on demand. I'll also add to your kind of question about size. I mean, the bigger the image you send, the more one of these paid services cost.
The more tokens, right?
Yeah. Okay. Yeah, although in our testing, it didn't vary as much as you would think. You know, an increase in image size, there isn't a similar proportion of increase in the number of tokens being used.
I assume that you've been using only images from your own repository. But
no, they're from all over lots of different
great.
places. Yeah.
Oh, then
Anywhere, any IIIF manifest that you can load in, you can send, and it will handle it. So
true, like you mentioned, some of them are slightly slower than the others.
That's to do with the particular inference provider that's been chosen and the size of the model. So you could be running your own infrastructure and sending it to your own compute, or you could be running a local model. We have one example there. Or you're sending it out to something like Hugging Face, who have, per token inference available. And there is some variation in how quick they are. So that's something to kind of experiment with. So part of what we've been doing is working the kinks of that out, so it's a little bit smoother for the end user. But yeah, some are slower than others. And yeah, there is some slight difference with image size, but it doesn't seem, in our experiments anyway, to be a major factor.
Okay.
That we found.
Thank you.
Okay, I have a question for no one but Marlo at this time. So the plugins, you had said, I think you said, events available to plugins. Would you say all events through the Redux is published, or do you have like curated list of events? And relatedly, for the analytics example you mentioned, would you say all user interactions can be captured by the plugin?
Yeah, just to respond to that last part, we designed the plugin in the way we wanted as far as which events we wanted to capture, but because the background events are firing continuously through Redux, it's pretty much you can choose whatever you want. So we capture things like maximizing the window going to full screen, or opening the side panel, entering a content search to the IIIF content search API. We can capture those search terms and all of that stuff within the viewer that might not just necessarily come from like a GA page load event. So yes, I would say that like all of the events are open to a custom analytics plugin, but you can pick and choose if you don't want to be flooded with all of them. And I guess what I was trying to say in the last slide about our goals upcoming for developer experience is basically, yes, all of the events from the Redux stuff is available to a plugin development. That's true, but it does take some digging into the Mirador internal. So we want to make that packaged in a nicer way and better documented toward basically what developers are trying to build. So the answer is yes, but we are trying to make it a little more ergonomic and easier to just kind of take off the shelf and use. Hopefully that helps.
Okay, thank you.
Yeah, I was just wondering about the Mirador, the plugins. Do they require a local instance of Mirador running, or can a CDN package of Mirador be used alongside the plugins?
That's a great question. That's something I'd like to talk to you more about that. We do currently require you to repackage the whole thing, so you do need to use the full sort of like unpackaged version of Mirador to then to work with in development. But we've had that request and kind of are like working on making that release a little simpler. We do have a CDN plugin of packaged Mirador. But yeah, it can get complicated with like different versions of React and all the dependencies. But, yeah.
Thank you. Can I add another Mirador one? Sorry. Years ago, there was someone who tried to wrap it to make it like an Electron app around Mirador, so it was a local desktop app. Did anything come of that, do you know of? And is that going anywhere?
I've not heard of that, so I don't have a good answer for you.
Okay, fair enough. Thank you.
And why don't we have this one be the last question?
How about let's teamwork that back?
Thanks. This is just a comment on the last question. We have a Docker implementation that allows you to run Mirador on a static data set with plugins on your local machines.
Okay, can we have a round of applause for our speakers in this session? For those of you looking at the clock, it was 3.5 hours ago when Caitlin gave the instructions for lunch. In order for you not to have to pull that from long-term storage, we're going to have her repeat the lunch instructions and other information.
It's like a casino in here. There's no time and no daylight. That's it. But so we're going to move into lunch now. There are 2 rooms. The food's the same in both, but you have an opportunity to really spread out and explore the space. Vegan, vegetarian, and fish is all clearly marked. If you have a very specific allergy, celiac disease, a nut allergy, they have asked that you speak to the catering staff so that they can make sure that you don't inadvertently eat something you can't. And then when we come back here for the 3rd set of presentations, we're going to have presentations and also a super lightning round of poster introductions. I'd ask that the people who are presenting posters make sure that you're in the front because you only have 1 minute to present and you don't want to spend it coming from the back. So with that, we'll see everyone back here after lunch.